video, I'm going to talk about pie charts, right? So basically, you might be thinking, what is a pie chart? Well, a pie chart is just sort of a way of representing the proportions of certain things. You only need one measurement for each thing. So, for example, I don't know, let's see the percentage of people who catch a certain disease, the percentage of people who buy a house in their lifetimes, or sort of the proportion of people who catch, you know, several diseases, what proportion of what gender or what proportion of what age group, something like that, right? And you get like a circular chart and it has kind of slices in it, and it's like a pie with slices of the pie. You could even call it a cake chart, but it's not called a cake chart, it's called a pie chart, right? First of all, we'll start with slices, and we'll say that our slices are going to be, we'll give them some numbers. And we'll say that, I don't know, 9 people from our study group got X disease, 12 people here got X disease, 33 got X disease, 12 again, and then 17, right? And then we're going to say our items. We're going to say that our items are, I don't know, racial groups, because certain racial groups and ethnic groups are more susceptible to diseases. So, I don't know, we'll say Asians, we'll say, I don't know, Caucasoid, or we'll say Africans, general. We'll say Caucasoid, which just means white people. We'll say Latinos, which I'm sure everyone knows what a Latino is. And then we'll say, Asians is kind of just a big group. And we'll say Aborigines, as in Australian Aborigines, right? And then we're going to say, I don't know, we're just going to plot this, right? We'll say plt.pie. And the way we plot this is the first thing we plot are the slices. And then the second thing we plot are the items as labels. So we're going to say labels equals items. Don't worry, this will all make sense when I've actually made it. Okay? Now, let's run that. And I see here, we've basically got a chart, like I said, a circular chart that's like a cake or a pie, but it is called a pie chart and not a cake chart. And it's got a bunch of slices. With the slices, we can basically see what kind of proportion, has been affected by whatever or is whatever. So we've got Caucasoid here, we've got Africans, we've got Asians, we've got Aborigines, we've got Latinos, etc., etc. You can see there's a hell of a lot of Caucasoids who are affected by this disease. In fact, I'm just going to copy and paste all this. I can just copy and paste the plt.py. What I'm going to do is I'm going to make a better version and I'm going to add a title. So I'm going to say plt.title. It's going to be called races affected by, or proportion of races affected by XEX disease, right? This is an imaginary disease, and I'll just make this chart again. Right, see here we've got our title, so we see that it's the proportion of races affected by this disease, and you can see there's a lot of Caucasians who are affected by this disease. You can see there's more Aborigines than every other group apart from Caucasian. For whatever reason, Asians just aren't very affected by the disease when you look at the proportions. It could be that the disease is spreading in, Europe, and so you aren't seeing as many Asians infected. Could be many reasons, right? But this is just kind of an example of a pie chart and what it'd be used for. Now, there's a few things we can change if I just copy and paste all this once again. One thing is the colors. You might notice that we've got all these colors here, and we might want our own colors, right? So we can change the colors argument here by basically importing an array. We could actually use a pre-built array if we want to put all our colors into an array, like I've put the items into an array here. But I'm just going to, type them in the argument itself. And we're going to say, I don't know, pink, blue, orange, yellow, and grey. I don't know if grey exists as a colour on this or not, but well, we'll soon find out. It either gives me an error or it doesn't. So here you can see we've clearly changed all these colours, with Asians now being pink, Africans being blue, Caucasoids being orange, Latinos being yellow, and Aborigines being grey, right? So if for whatever reason we want to change the colour, we can. We don't have to stick to these standard pre-given colours if we don't want to, right? And like I said, you can actually just make an array and import the array instead of doing what I've done here. In fact, in the next one, that's what I'll do. So we'll copy and paste this. And we'll add a couple more arguments just so you can see kind of the variation you get here. So we'll say color P. I don't know, color P. Not sure why I've called it color P. P's aren't necessarily very colorful. In fact, they're just green, but you know, whatever. And if I paste that in there and replace this argument with just color P, this should give us the previous colors. You can see that I'm not lying about you can put it in an array outside of there. Right. Now, the next thing we can actually change is the start angle, although the start angle is currently 90 degrees, so we won't see a difference. If I change start angle, we'll make it equal to 90. You should see a little, well, I don't think you'll see a change because I think it looks like it already starts at 90. Yeah, and if you look, there's not much difference. There's not really much difference. It still starts at 90 there. But hey, you know, we started it where we started. We started at Africans at 90 degrees like this, right? But that'll just change the layout a little bit. We don't really need to do that as such though. If I copy and paste this over again, I don't need to copy and paste color P because we've already made that variable. Don't need to make it twice. I will show you something called shadow, something called explode. Don't worry, got nothing to do with bombs, and something called auto PCT, which is automatic percentage. Just cut this back a little bit, and I'll add two things. I'll add shadow, and we'll say shadow equals true. And then, actually, I'll just add shadow, and then I'll add explode later. So F9. You can see we've got this shadow here. So if we look at the last one, there's no shading here. But if we look at this one, we've got a shadow. I'm not sure how the color works. It might be default. Maybe you can change it. I'm not entirely sure. I'm just kind of showing you that this exists so you can change your representation in that way. Right. Now, another representation is explode. So I'm going to get rid of the start angle difference and the shadow here. I'm just going to put explode, right? And like I said, don't worry. This isn't anything to do with bombs. What it basically does is it'll take, you know, a part out of your chart, right? So let's say we want to explode the third item, which is Caucasoid. Well, in the array of slices, it's going to be 2. So we want to explode the second item. So let's say we don't want to touch the first item, we keep it at 0. The second item we don't want to touch. The third item will explode 0.3. We won't explode Latinos, and we'll explode Aborigines by 0.1, right? I won't tell you what it does because you're going to see the effect here. Oppositional argument. What's wrong with that? Follows keyword argument. What do you mean? I'm not really entirely sure what's happened there. That should be fine, really. Maybe I should put that before it. I don't know. Let's just try that, I guess. So we'll just try and put that before it. Don't know really what happened there. Should be fine. Well, that's now invalid syntax because I've got 2 of them. Let's have a try of that. Let's see what that does. Positional argument follows keyword argument. I mean, I can't really do anything about that, can I? Do I have to put explode equals? Yeah, there we go. I just needed an equal sign. Right. So if you look at this chart, we can actually see here is that where you've exploded it, these sections, these slices have actually been sort of taken out and highlighted so you can see them better. Now, Latinos and Asians and Africans, you can see they're completely connected because they haven't been exploded. Latinos has been exploded by 0. Asians and Africans has also been exploded by 0. So they haven't been kind of moved out of this chart. And the reason that you'd move, say, Aborigines or Caucasoid out of this chart is just so that you can kind of highlight them, you know. Really, we probably wouldn't move Aborigines out of the chart. In fact, I'll give you kind of a better like sort of display of how we'd probably use explode. We'd probably use it by we probably only explode Caucasoid. The reason we do that is because I don't know. Let's say we live in Russia, or this is a Russian experiment. You don't really have Latinos, Aborigines, or you might have some Asians actually, or Africans in Russia. So it's not really very interesting what's happening to them in terms of the disease. Let's say COVID, for example, because you need to know what's going to affect your population, right? So here, this is probably what you do, and like I said, like in Russia, in northern Russia, because most people are Caucasoid race, and you can see here exactly what kind of effect it's having on Caucasoids as opposed to what effect it's having on the other races, right? Which, like I said, would be useful if you're in Russia. If you're in Africa, for example, you'd explode the Africans part because that's what's relevant. That's what you want to know about, right? You don't want to know about the other races as such because you don't necessarily have a high proportion of them in your country. Right, so the next thing and the last thing that I'll show you, and I'll have to get rid of the, well, I don't have to, but I'd like to get rid of the explode here, just so you can kind of just really get a good appreciation of properly how it works. Hopefully I don't mess this one up. So there's an argument called auto PCT, right, which means automatic percentage, right? And we're gonna just put a string in here. Now don't worry about the string, just use it. Okay, I can't actually explain exactly why it works, and I wouldn't want to know. I just want to know how to set the percentages, and I'll show you what it does. Basically, it shows you what percentage of the overall number. So what it'll do is, I imagine it sums up all of these slices, and then it'll divide them by 5, and it'll tell you what percent every single different, labeled item is, right? So our items are this Asians, Africans, Caucasoid, etc., i.e. our labels here. And you can see, Caucasoid has the largest percent at 39.8% of Caucasoids are affected. Might be because you have a higher Caucasoid population, but, we're just looking at this. And you can see, Latinos and Africans, they're the same sort of infectability or, they're just as affected as each other, much less affected than Caucasoids. Asians barely affected, and Aborigines, they're halfway between, they're halfway to being as affected as Caucasoids, right? And it's interesting because we can see what percentage, how it relates to the rest of the pie chart. See what I mean? Well, anyway, that's about all. Thank you. I hope you enjoyed it.